Okay, well, what I'm going to talk about in this video is a little bit about what is chemistry and what we're studying, but I'm going to segue into properties of matter and changes of matter. I'll explain what all that means in just a little bit. So, start with the basic question of what chemistry is a study of. And chemistry is the study of matter. We're going to talk in this class about characteristics, meaning what is it like, the composition, what is it made of, and transformation, what does it do. All of this talking about matter. Now, there's a few videos here where I want to talk about matter and classifying it and just sort of sorting out what it is. But matter is kind of a weird concept. It's something we kind of all understand, but it's hard to codify into a specific definition. Now, it's funny, your book has a rather circular definition, which is what I'm going to use here. I'll expound on this a little bit, but really the circular definition is going to be fine for this class. I'll explain why it's circular. Matter, as defined by your book, is anything that has mass and occupies space. Well, occupies space we can get. I can't be in the same place as some other piece of matter. I can't walk through my desk. I can't walk through a wall. It occupies space. I can't occupy that space. We're both matter. We kind of get that. Anything that has mass. Mass is a little bit of a weirder concept. And so your book, this is where the definition is circular. Mass is referred to in your book as the amount of matter present. Well, that doesn't really tell me anything. You just said that matter has mass, and mass means it's matter. You don't need to know this, but really where the idea of mass comes from, there's actually two definitions of mass. Mass has to do with how much something is affected by the Earth's gravity. So in other words, how heavy it is, how much it weighs. And how much it resists movement. So if I try to push, by the way, you're going to learn very quickly, I'm a terrible artist, but I'm trying to push this box this way. The more mass, the more it resists being moved. Even moving, not considering friction or its weight. Even if I were out in the dead of space and I try to move this box, a heavier box, heavy is referring to weight. A box with more mass will take more energy to get moving. It has more inertia. So there's two definitions that work together. One is called gravitational, and the other one is called inertial mass. You don't need to know this. I just thought you might find it interesting. Really, just knowing that mass is how much matter is present is totally fine. It's perfectly good for this class. I did segue just in that definition there, something that is important, that mass and weight are different. Weight is actually the measurement of the gravitational force acting on the mass. So on the Earth, there's a constant gravitational pull on massive objects. Something that has twice as much mass will have twice as much weight. But what's important about the difference between mass and weight is if I took an object to the moon, its weight changes, but its mass doesn't. We'll talk more about that in Chapter 2, but just as sort of a little intro to this idea. Okay, so now that we have an idea of what matter is, let's talk about properties and changes of matter. So properties of matter are what matter is like. Basically, it's its characteristics. So matter, and I can't get the story, there we go. We use characteristics or ways to describe objects all the time. That brick is red and solid. That car is blue. There is a green gas. We use these terms all the time, these color and what form they take. Chemists call these properties. That's the word that chemists use to describe it. So this is characteristics or descriptions of substance, of matter. So properties fall into two basic types. Changes, which I talk about in a minute, will also fall into these same two basic types. One are physical properties. The other are chemical properties. So physical properties, and so this can be a little tough to get your head around. Physical properties are characteristics of a substance that can be observed without changing or even attempting to change the basic identity of the substance. So physical properties are things like color, odor, the physical state, by physical state I mean solid, liquid, gas, that sort of thing. Let's see what else. How hard they are, how much they weigh, their density, temperature, anything you can measure or observe without, we're not talking about how the substance changes in any sort of reaction. We're just talking about what it is, what it's like, its physical state, basically, how it is right now. Chemical properties talk about how the substance undergoes or resists. Now this one's really critical, this resists thing, how it undergoes or resists changes to a new substance. So, examples, as I said, examples of physical properties are like color, physical state. I didn't mention this. Melting point and boiling point. So, water is a liquid. That's a physical property of water, right? I'm not describing how it changes or resists changes to chemical reactions. It just is a liquid. It freezes at or below 0 degrees C or 32, I can't write, 0 degrees C or 32 degrees Fahrenheit. This is its melting point. Freezing point and melting point are the same thing, right? Because if you go up from below 0 degrees C at 0, it melts. And if you go down from above 0 degrees C at 0, it freezes. So the melting point and the freezing point are literally the same thing, just to clarify that. However, this is a physical property. The temperature at which it changes from solid to liquid, or the boiling point, the temperature at which it changes from liquid to gas or gas to liquid. Why is this a physical property? The answer, I just realized, it still is up on the screen right now. Ice is still fundamentally the same substance as water. At the molecular level, ice and water are the same thing. Freezing something or boiling it, these processes don't change what the substance fundamentally is. So, freezing point and boiling point are physical properties. Chemical properties are things like iron rusts when exposed to oxygen. Gold does not rust when exposed to oxygen. This one's a weird one. This one takes a minute to get your head around. It didn't rust. But what I'm describing is what it does and doesn't do chemically. Gold is resistant to rusting. It's resistant to reactions with oxygen. That is a chemical property. It'd be very weird to say this substance, something burns is a chemical property, but something doesn't burn as a physical property. If we're talking about trying to react it or it not reacting, anything along those lines is a chemical property. So even when a substance resists the change, it's how it reacts and doesn't. It's something being very inert and stable is still a chemical property. So there we go. Oh, weird. All right. And I'll throw these into my slides from time to time. So what I want you to do is take a moment, and I want you to try to answer these questions here. So these are all properties of magnesium. I want you to determine whether they are physical or chemical. So go ahead and pause the video and try to answer that. So, solid at room temperature. So this first one is just describing its physical state. So this is definitely a physical property. Ignites upon heating in air. Igniting, anytime we burn anything, burning is a chemical process. So remember, even if I said it doesn't ignite upon heating in air, that would still be chemical. So ignites upon heating in air is a chemical property. Hydrogen gas is produced when it is dissolved in acids. That may be a little tough, but the fact that we're producing a whole nother substance out of it, that's a good giveaway that we're talking about a a chemical property and has a density of 1.738 grams per cubic centimeter. We haven't even really talked about what density is yet, but density is definitely a physical property. Okay, now, not to try to drag this video out too long, I'm going to talk about changes also, but this follows right on the heels of properties. We're still going to break them down into physical and chemical, but changes are just a slightly different way of phrasing something. Changes are, and in fact, a chemical change, which I'm going to talk about in a minute, is actually just a reaction. So this is more of the action type. Properties describe what something is capable of. Changes are talking about right now, this is what it's doing. So in other words, saying, I am capable of jumping X distance. That's a property of me. I am capable of doing it. That person is actually jumping that distance. That's a change. It's a little bit, maybe a little weird to think about the two. But one is just saying the potential, and one is actually happening. Changes also fall into two types: physical and chemical. Physical changes, a little more cut and dry. If a substance is changed, and its physical appearance is changed, but not what it's fundamentally composed of at the molecular level, then it's a physical change. So this is if I break glass, cut something, cut paper, melting, boiling, that's important. Phase changes. So like dry ice, subliming away into CO2 gas, that is a physical change, not a chemical change, because it's still the same substance. Chemical changes at any time the substance undergoes a chemical composition, or a change in chemical composition. So words that you should be looking for that indicate chemical changes: rusting, corroding, digesting, decomposing, tarnishing, burning. I'm sure there's a bunch more that I can't think of right offhand. But now I'm going to do a couple more of these problems here, but I'll let you know right now that a few of these are a little tricky. I want you to take a look at them. And it's also a good time to get used to the idea that I'm not trying to be tricky. I'm not trying to trick you. I want you to think fully. Don't think about it in the sense of, this is a test question, or this is a question, and I've got to do it this particular way. Just answer the question to the best of your ability. So, and if you think something's amiss, or you think there's an important caveat, say that. So, pause it and go through these and tell me which of them are chemical or physical changes. So milk souring, right? When milk spoils or sours, it curdles, it changes its taste, it separates into two different things. This is a chemical process, for sure. Oh, it's not showing up. I'll just have to write it down. This is a chemical process. Oh, now it's showing up. Nice. Limestone. I crush it with a hammer. Right? I smash a piece of limestone with a hammer. That is a physical change. I didn't chemically change it in any way. I just broke it into pieces. Now the next one, I throw a ball through a glass window. That's, of course, physical. I'm just breaking the window. I'm not changing it from glass into anything else. Tree leaves change colors. This is chemical. Now, this may be weird. So remember, color is a physical property. But most of the time, there are some really weird exceptions that have to do with chemistry we haven't learned yet and aren't going to learn in this class. Most of the time, a color change is indicative of a chemical change, because color comes from the chemical bonds at the molecular level. The color won't change unless those bonds change or break. So that's why observing the color is a physical property, but in order for color to change, most of the time, that's a chemical change. So for the purposes of this class, I want you to always consider that a color change is a chemical change. Now, you may say, well, Steve, I can paint over a white wall with red paint, and now I've changed the color, but I didn't change anything chemically. That is not really a chemical change either. Think for a moment about why before I say. The reason that's not a chemical change is because you're not actually changing the color of the white paint. You're just putting something red over top of it. Underneath the red paint, that white paint is still there and it's still white. You didn't change it. You just changed what color is on the wall. You didn't change the color of the paint. Last one, a candle burns. Now, honestly, both answers are right here. It depends what you're talking about. If you think about the wax, the fact that as a candle burns, the wax melts from solid to liquid, that's definitely physical, because that's just a change from one state of matter to the other. The wick, however, that wick that runs through the candle, that's actually burning. That's actually undergoing a chemical change, burning it up into carbon and gases and things like that. So, there we go. And that's really all I have to say about physical and chemical changes. That's it.